Hello and welcome to the Maths Behind Economics YouTube channel. We are still working with exponents and this is our 10th video. Today we're going to look into how to raise fractions to a negative power. As always, we're going to remind ourselves what the rule is. Then we talk about why the rule works. Again, show you the intuition and then work into formal proofs. And in the last part of the video, we'll look at some examples. So let's do it. And just as in the other videos in the series, let's start by reminding ourselves what the rule is like. Okay, so we got a over b, and all together we're going to raise it to the negative power now. Okay, and then the rule says that this is going to be b to the n over a to the n. And again, just like in the previous videos, I really want to draw your attention to that ab to the negative n is not equal a to the negative n over b. Again, I'd like to draw your attention to the bracket in algebra. The brackets in mathematics always signal that the normal generic priority have been altered. So the left-hand side tells me that everything inside the bracket, the whole fraction, have to be raised to the negative n power, while on the right-hand side here, it's only a that needs to be raised to the negative n power and b will not be touched. Right, so let's look at why this rule works. Okay, so why is this rule working? And again, as always, starts with a generic example. 2/3 raised to the negative 5. I'd like to show you why the rule works with specific examples first, and then we can move on to the generic notation with just letters. Now, what we're going to do here is going to remind ourselves what it means to raise something to a negative power. Well, that is just 1 over the positive equivalent of that same power. So 2/3 to the 5th. The only difference here now is that we got a fraction, not just a simple number in the denominator. From here on, I can again use the definition of the exponent. So what it means for raising 2/3 to the 5th power. Well, I'm going to have 1 at the top, because that doesn't change. And then I'm going to have 2/3 multiplied by itself 5 times. Okay, 1, 2, 3, 4, 5. Lovely. Again, how do I multiply a fraction by another fraction? Multiplying the numerator by the numerator and the denominator by the denominator. So what I can do here, I can replace this as 2 multiplied by itself 5 times at the top, and then 3 multiplied by itself 3 times. Sorry, 3 multiplied by itself 5 times at the bottom. So let's make sure that we got everything. 1, 2, 3, 4, 5 2s and 1, 2, 3, 4, 5 3s. And again, that is just going to be 2 to the 5th over 3 to the 5th. Now, what happens in here? I've got a whole number over a fraction. Remember, a fraction line is actually nothing else but a division. How do we divide by a fraction? We multiply by the reciprocal. What's the reciprocal? Is the fraction turned upside down. So the bottom number comes to the top number comes to the bottom. Or if you like to use the fancy mathematical terminology, you can say that the denominator becomes the numerator and the numerator becomes the denominator. Either way, the final effect will be 3 to the 5th over 2 to the 5th. Now, last step in here, anything whatsoever multiplied by 1 is always just itself, so we can just replace the whole thing as 3/5 over 2/5. Now, I could have done this a little bit faster, because I could have used what we learned in the previous video. I could have simply just skipped these 2 steps and replace the fraction here by here right away, because we've shown in the previous video that the 2 circled fractions are absolutely equivalent with one another. However, if you haven't seen that video, you can still follow through the exact logic and you can still see why that works. So that's how we dealt with one specific example, but examples are just those examples. We have to make sure that the rule works every single time with any number. So let's apply the same logic, but in this case now only use letters. So a, b to the negative n. Again, we use the negative exponent identity. So it's going to be 1 over ab to the n. next, I'm going to skip these definition applications, and I'm just going to use the identity in the previous video. So that's going to be an over bn. Again, remember, a over b to the n is equal a to the n over b to the n. If you don't remember that, check the previous video. I'll link it for you. Now just we need to remember what happens when we need to divide something by a fraction. So that's just multiplying by the reciprocal. Switch a to the n over b to the n to b to the n over a to the n. And again, anything multiplied by 1, just going to give itself. So b to the n over a to the n. And voila, this is why the rule works, and this is why the rule works every single time with any number or variable. Right, so let's look at some examples. I'm going to make more space so we don't have to scroll down by much. So examples. 3 over 5 to the negative 7. Now that's going to be 5 to the 7 over 3 to the 7. Remember, we switch the numerator and the denominator. So whatever was at the top, now at the bottom. Whatever was at the bottom, now at the top. Next example. Minus 2 over 7 to the negative third. Well, minus 2 is at the top, so that goes down at the bottom. And 7 is at the bottom, so that goes at the top. And then the power becomes positive, so that's positive 3 and that's positive 3. And again, we can replace the bottom number by negative 2 cubed. Next example, b over 5 to the negative 6. Again, switch the fraction around, 5 over b, and each of them separately to the same power. Next example, 2 over x to the negative 2. Same drill. X comes at the top, 2 goes down the bottom, and now each of them raised to the same positive 2 power. Next one, 2x over y all together raised to the negative 10. Well, switch them around, y over 2x, and then raise them to the positive power, but remembering that both the 2 and the x have to be raised to that very same 10th power. And again, we can use the multiplying the different numbers together but raising them to the same power rule. That's going to be 2 to the 10 and x to the 10. Last example for the video, v over 3s all raised to the negative 5th power. Again, switch them around, 3s over v, and because 3 and s are multiplied together, but they together have to raise to the 5th power, I'm going to write a bracket around them. So that's going to be 3 to the 5th times s to the 5th over v to the 5th. I hope now that you understand why this rule works and why this rule works with every single number or any number and variables. And see you in the next video. Bye!